All right. Today we're going to take a journey past the screen, past the keyboard, and go deep inside your computer to get to the very core of how it actually thinks. We're going to break down two words that, honestly, control everything you do on your machine: memory and storage.
You know that feeling, right? You're deep in the zone, maybe typing up a super important document, and bam, the power flickers, and it's just gone. Poof, vanished. But then, all the files you saved yesterday, they're totally fine. So what's the deal? Well, that very moment of frustration, believe it or not, holds the key to the whole story.
See, it all boils down to these two completely different worlds: memory and storage. The best way to think about it is like this. Memory is your computer's temporary workbench. It's messy, it's active, it's where you're doing all your current work. Storage, on the other hand, that's the permanent library, or maybe a big filing cabinet. It's where you put things away for long-term safekeeping once you're done with them.
Okay, so let's start with that workbench, the computer's short-term brain. The technical name for this is primary memory, and this is where all the fast-paced, in-the-moment action really happens.
Now, the star of the show here is RAM, which stands for Random Access Memory. Anytime you open an app, or a photo, or a web browser, that stuff gets loaded into RAM so you can get to it instantly. But, and this is the big one, RAM is volatile. And that's just a fancy way of saying when the power goes out, that workbench gets wiped completely clean, instantly. So if RAM is that temporary workbench, you can think of its partner, ROM, or read-only memory, as the computer's unchangeable instruction manual, the one that's bolted to the wall. ROM is non-volatile, meaning its contents are permanent. It holds the super basic, super critical instructions your computer needs just to turn on and know what to do next. It's the stuff that can absolutely never be forgotten.
But wait, there's actually another layer here, and it's even faster. It's called cache. Imagine you're at your workbench, but you keep your favorite screwdriver right in your pocket. That's cache. It's a tiny, lightning-fast bit of memory that basically guesses what the processor's going to need next and keeps it ready to go. It saves that extra millisecond of reaching over to the workbench.
And this table really lays out the big trade-offs. Just look at that speed column. Cache is just ridiculously fast. That's why your computer feels so snappy. But it's volatile, it's temporary. Then you have RAM, the main workhorse for everything you're doing right now, also volatile. And way down at the other end is ROM. It's permanent, non-volatile, but it's much, much slower. You see the pattern? It's this constant balancing act between speed and permanence. Okay, so that covers the workbench. But what about that big filing cabinet? Where do your files go when you actually want to keep them forever? Well, that's where secondary storage comes in. This is the solution to that whole power outage problem we started with. When you hit that save button, you are literally telling the computer, hey, take this thing from my temporary workbench, the RAM, and put a permanent copy away in the filing cabinet. Because this storage is non-volatile, your files are totally safe and sound even when the power's off.
Now these days, that digital filing cabinet usually comes in two main flavors. You've got the classic hard disk drive, the HDD, which uses spinning magnetic platters. Kind of old school, but fantastic for storing huge amounts of data for cheap. And then you have the modern solid-state drive, or SSD. No moving parts, it's all flash memory. It is way, way faster, which is why a computer with an SSD feels so incredibly snappy when it boots up.
Okay, so workbench and filing cabinet. Simple enough. But let's be real. What happens when you're a serious multitasker? You've got 50 browser tabs open, a video editing program running, plus music. What happens when your workbench, your RAM, just gets completely cluttered and runs out of space?
Well, this is where your computer pulls off a truly brilliant magic trick. It's called virtual memory, and it's how your computer pretends it has a much, much bigger workbench than it really does.
So here's the trick. When your RAM gets too full, the computer looks around for stuff you haven't used in a little while, like that browser tab you opened an hour ago. It takes that page of data and quietly shuffles it over to a special corner of your big, slow filing cabinet. This frees up precious space on the workbench for what you're doing right this second. It's this constant, clever swapping game happening in the background, all to make it feel like you have way more memory than you actually do.
So we have this amazing system for storing all our stuff. But we've got another challenge. Our files are getting absolutely massive. I mean, think about high-resolution photos, 4K videos. How on earth do we make all that fit and send it over the internet? Well, the answer is a little thing called data compression.
To put it simply, data compression is the art of making files smaller.
It's like digital origami. It finds these really clever ways to represent the exact same information, just using a lot less space. Honestly, it's the magic that makes things like streaming movies or emailing a photo even possible.
And compression really comes in two main flavors. First, you have lossy compression. This makes files way smaller by strategically throwing away tiny bits of data our eyes or ears probably won't even notice. On the other hand, you've got lossless compression. This is more like a math puzzle. It finds a way to shrink the file without losing a single original bit of information.
You are using lossy compression all the time without even thinking about it. Every JPEG photo you see, it's thrown away tons of color information your eye can't perceive just to shrink the file size. For media like photos and music, it's a fantastic trade-off, where good enough is pretty much perfect.
But what about when good enough could be a complete disaster? Well, that's where lossless compression comes in. Think about a zip file that contains a program or a document. You can't just lose a few bits of data here and there. Lossless guarantees that when you unzip that file, you get a perfect, bit-for-bit, identical copy of the original. Every single piece is crucial.
So let's zoom out. How do all these different pieces, the super fast cache, the RAM workbench, the big filing cabinet, how do they all fit together? Well, it's not random at all. It's actually a very carefully designed system called the memory hierarchy.
Really, it's a brilliant balancing act. Think of it like a pyramid. At the very tip top, you've got that tiny, crazy expensive but lightning-fast cache. Right below that is your main workbench, RAM. Bigger, a little slower, a little cheaper. And at the very bottom, you have massive, slow, but super cheap storage. This whole layered system is designed to give you the best of both worlds. Pure speed right where you need it for active tasks and massive capacity for everything else.
And that brings us to one last big question. You know, with things like virtual reality, artificial intelligence, our demands on our computers are just growing exponentially. So you have to wonder, as our data gets even bigger and our apps get even more complex, are these clever tricks and this elegant memory pyramid, are they going to be enough to keep up with the demands of tomorrow? It's definitely something to think about.